Now we'll learn about acceleration. First we'll ask, when is a body said to be accelerated? If the velocity of the body is increasing or decreasing, the body is said to be accelerated, which means a body with changing velocity is said to be a body in acceleration. So here, when the velocity of a body changes, it is said to be accelerated. Now let us consider an example of a body which is at rest. Rest means the velocity is 0 meter per second. And after about say 5 seconds, time equal to 5 seconds, the body speeds up. And now its velocity becomes 10 meter per second. You'll definitely agree this body has accelerated. Why do I say the body has accelerated? Because its velocity has changed from 0 meters per second to 10 meters per second. So the initial velocity of the body, which we'll call as always u, we call it as u, was 0 meter per second. And the final velocity v is 10 meter per second. And the time taken for this change, we know is 5 seconds. So let's see what is the acceleration. So acceleration is the rate at which the body changes its velocity. So acceleration is given as acceleration is given as final velocity minus initial velocity over time. So acceleration, final velocity was 10, initial velocity was 0, and the time was 5. So acceleration is 10 over 5, that is 2 meter per second square. Which means for every second, the body increases its velocity by 2 meters per second. So I repeat again, when I say acceleration equal to 2 meter per second square, which means for every 1 second, the body increases its velocity or changes its velocity by 2 meter per second. That is acceleration. So if we were to define acceleration, we would have defined it as the rate of change of velocity. Rate of change of velocity. Rate of change of velocity with time. It could be an increase in velocity or a decrease in velocity. Let us take another example. Here we will take an example. Suppose a body initially is say at 20 meter per second, and then it increases its speed to say 100 meter per second, and it does this in time of 20 seconds. Let's calculate its acceleration. So we know the initial velocity is 20 meter per second. We call that initial velocity as u. Final velocity is 100 meter per second, which is v. And the time taken for this change is 20 seconds. So this body is accelerated. Why do we say this body is accelerated? Because it has changed its velocity. Now, how fast has it changed its velocity? Every second, how much has it changed? We use a formula. Acceleration equal to final velocity minus initial velocity divided by time. The final velocity was 100, the initial was 20, and the time was 20. So this became 80 over 20, and now this is 4 meter per second square. So for every 1 second, the velocity has increased by 4 meters per second. So we defined acceleration as the rate of change of velocity with time. The unit of acceleration we have to remember is meter per second square, or you can written meter s minus 2. Another thing we have to remember is acceleration is a vector quantity. Means it has got both. It has got direction as well as magnitude. And when is a body said to be accelerated? When body changes its velocity. When a body changes its velocity, the body is said to be accelerated. So when does a body change its velocity? Two things. Velocity has got two parts. It has got direction and magnitude. So if a body changes its direction, it changes its velocity and it is said to be accelerated. Or if a body changes its speed, it also said to be accelerated. So if direction is changed, that means velocity is changed. Velocity is changed means the body is accelerated. If speed is changed, also velocity is changed. And if velocity is changed, body is said to be accelerated. So if I consider an object moving in a circle, okay, it's moving in a circle with a constant speed of 5 meters per second. Speed is constant. Is the body accelerated? It's not enough to see speed. We have got to consider the direction. Now remember, when an object is moving in circular motion, it changes its direction all the time. To understand this, if you take a cycle and if you want to remain in a circular path, do you keep the handle of your cycle straight ahead, or do you have to keep it turned all the time? And definitely you will tell me you have to keep it turned all the time. The minute you keep the handle of a cycle straight, you'll get out of the circular path. So remember, in a circular path, you are changing direction all the time, like this. You're changing all the time, you're changing your direction. Even in a car going in a circular path, the wheel has to be turned all the time. So although in circular motion here, the speed is constant, but direction is changing. Direction is changing. So what do we say? Is it accelerated motion? Yes, it is accelerated motion. Because although the speed is constant, the direction is changing. So the velocity is changing. Now let's take another example. Suppose here you have a person moving along this path like this. See, not a straight path. It's moving along this path, but with a constant speed of say 15 meter per second. This body is moving. Constant speed. Speed is constant. Can you say it is accelerated? So remember, velocity, it has to have same velocity. Velocity has got two aspects. Which are the two things of velocity? It has got magnitude, which is its speed, and it has got direction. For velocity to remain constant, both should remain constant, magnitude as well as direction. But in this case, have you seen, the direction is not constant. See, this is the direction. At this point, this is the direction. At this point here, at this point, this. So although the magnitude is constant here, the speed is constant, direction not constant. So that means velocity is not constant. Now, if velocity is not constant, it is said to be accelerated motion. So here I can say all circular motions. All circular motion are accelerated, because to remain in circular motion you have to change direction. So even if your speed is constant, your direction is changing. Hence all circular motions are accelerated motions.